All right, everybody. Thank you for joining today. Looks like we got a pretty good crowd here. So this is the sort of kickoff meeting for our work group device management, which is not even an official work group yet, but hopefully it will be before our next meeting. So let me display my screen. I put together an agenda. I wanted to start with kind of organizing things, and then I'm sure there'll be plenty of other things people want to talk about if you have time for more. Okay. Um, okay. So yeah, just mostly start out with welcoming everybody. So I know a number of you were at QCon EU, and I'm sure the rest of you have seen email we sent out. But we had quite a lot of discussions there. Um, Patrick and Kevin have been working on DRA for a couple of years now. And I've gotten involved more recently on trying to uh, move that forward and kind of maybe expand the scope a little bit or tweak the scope a little bit. Um, so what we're trying to do with this working group, originally DRA was being run out of working group batch, but there are other use cases for the use of these devices that is, not just batch-oriented workloads. Um, uh, Clayton and Sergey have proposed work group serving, which will help define those use cases and kind of the upper layer workload controller type of APIs and things for those non-batch workloads, similar to how batch does for jobs and things like that. But we do see space or a need for a group focused on the management of the devices themselves, the allocation of the devices, the selection, the kind of the workload APIs to select those devices, choose the right one, allocate resources from it, share them across workloads, or have workloads that consume multiple of those devices at a time. And those would be that's this group. The idea being that it serves provides a place to coordinate on those lower level APIs, which then are consumed by the workload controllers and people directly, for that matter. So I think people probably already know that, but that's kind of where we are. As far as the process of organizing, we do have a PR pending for creating the work group, and so there's a charter I put in there yesterday. So if anybody wants to review that, the link is there in the meeting notes. I think Kevin already made a comment or two. And then the way I was thinking about organizing this is that we have the stakeholder SIGs. So the SIGs that have the SIGs that, for those that aren't as familiar with how Kubernetes organizes its groups, the SIGs own all the code. So as a working group, we don't really get to own any code. We are short-lived, by short meaning probably 2 to 3 years. And we'll help coordinate among the SIGs. The SIGs actually own the things. The SIGs approve the things. Like, we just provide a place to coordinate and give some input and guidance. Ultimately, the SIGs make up their minds. They're going to provide us a bunch of input. So what I've asked for here is, from each of the kind of sponsoring SIGs for this work group, there to be one person that's the representative, just so we know who to go to when we have questions, and there would be the one that would come to this meeting. It looks like we've gotten volunteers from all of those SIGs, which is great, and one from work group batch as well. Work group serving doesn't exist yet, so I don't know who that will be yet. The second area, and I'll pause in a second to get questions, but the second area, a set of stakeholders that I think about isn't so much people in the Kubernetes community, like groups, but it's more the industry groups, the industry people who would be interested in this. So the device vendors. So here we're talking about those those companies that, make these devices that we're going to manage. So NVIDIA is one with their GPUs. Google has something called TPUs that we make, although I don't think we sell them separately. But we still want to make sure that the TPU use cases are represented. And then anybody else, so Intel has some devices they make, so I'd like somebody from Intel in that group. Similarly, there's the cloud providers, Kubernetes vendors, AWS, Google, Red Hat, Microsoft, others, ecosystem projects that are going to consume these APIs. So part of the goal here is, can we build a set of APIs that support ecosystem projects like external schedulers and autoscalers, things like Carpenter. So I want representatives from those groups. And then, of course, two different types of end users being like the actual workload authors that are like want to run stuff, and then end users being the cluster administrators who are going to sort of govern or manage access to these devices. So I'm looking for people from each of those groups. We've got some volunteers, but anyway, I'll pause here and for any questions or comments. All right. I don't see any. So in that case, I guess what I will do then is go through. Yeah, I see people. Okay, I have somebody on the chat. So if you want to volunteer if you want to volunteer to participate in one of these groups, just put your name in. And if you want, there's a couple of groups that we need somebody to lead on these groups. And all the lead means here is you'll recruit the people, you'll coordinate the people, and we'll come up with a set of deliverables from each of these groups as far as how they're going to contribute, provide their inputs. Neha.
Yeah, thanks, John. And thanks a lot for creating this group. I know we had this discussion over a KubeCon, and I am so glad that it's coming to what we had a small chat about. I want to add on to the share the document I've promised you. Maybe John, I've shared the link with you. Maybe if you think it's the right place, because there are multiple groups involved in it, and every working group has their own detailed docs, detailed use cases. There's a lot of scattered information. The purpose of the doc I created was to just up-level the message in a way where we think that information is required to make a specific change into the device management or DRA, whatever we're calling is important.
Yeah, that would be awesome. So to give context here to the other folks,
yeah.
Neha and a few of us were talking at KubeCon in Paris, and she volunteered to start a document where we could start to collect these use cases. So right now, for example, Kevin has a document where he's got NVIDIA use cases. There's another document that Patrick started that has some other use cases for some other vendors. But I think there's also not just use cases, but like requirements and things from the SIGs and from all the different constituencies. And so if we can try to coordinate in there, I think that would be really useful. So if you can add it to the Google Doc, a link to the Google from the Google Doc, you can just add, and then everybody will have access to it.
Yeah, let me add. Now, I want to highlight again, the purpose of this talk is to not cover the detailed scenarios of each working group. Please add your reference docs there. The purpose, add the information which we think is pivotal to make, which we think is required to make changes into the DRA, so that we can come up with then a second doc, like a design doc of what we think is we need to make some gap changes onto the DRA design. Does it make sense?
Yeah, for sure. I think that this, so maybe to give that kind of leads us into the next section, which is the kind of what we're trying to do in the near term. what the state of things is right now. And so I think that we have in 126, I think it was, right, Patrick? There was what we call classic DRA, which has a certain structure which allows people to build drivers to manage these devices and kind of create claims against those devices for workloads and provision and configure those devices. The issue that was raised was that it's too, in sense, it's too flexible. Like it allows the device, it doesn't provide any input or any data to the control plane to make scheduling, very limited data to make scheduling decisions, and no data to make kind of auto-scaling decisions. So essentially, it defers those decisions to an external driver, which makes certain kind of operations in the cluster and management of that cluster very difficult. So in 130, we worked to kind of revise that towards what we call our structured parameters model. And there we're kind of making some of that data available. And rather than making the decisions entirely outside of the upstream Kubernetes, we're providing the data for upstream Kubernetes components and ecosystem projects on top of that to make those decisions. So essentially, instead of saying, can what nodes can this workload run on by, and asking a driver that, the driver is publishing some information, and the scheduler is considering information associated with the workload claim and doing that comparison itself. This allows the autoscaler, for example, to do the same thing. So that's where we are in 130. We have that. It only covers, though, what we implemented in 130. As part of that is there's this model of how do I describe what resources are available, what devices are available, and what the details and attributes of those devices that are available are, and the capacity on those devices. And because we knew it was too hard to come up with the right model, we just came up with a model and built the machinery around it in 130. And the model we created covers, I think, what was it, Kevin, half of your use cases that Kevin had, but not,
yeah,
that's
5 out of 12. Yeah.
Okay, but so that's sort of like a first foray into this world of like trying to make a model that can satisfy these different use cases. So in 131, we have a few different things we need to address. One is extending that model so that we can cover the vast majority of use cases. I'm not going to say all use cases, but we're going to cover a lot of use cases. The other, and so some of those use cases are in here, some of these requirements. So per device resources, like being able to say that this particular GPU has this much memory, and therefore you can say, okay, I have a workload that requires X amount of memory, so I can give it a part of the GPU, or I need to give it 3 GPUs. Like you have to kind of decide based upon those comparisons. Partitionable devices. So can we support the fact that, for example, NVIDIA GPUs can be broken into smaller GPUs, and can we make those decisions at runtime rather than ahead of time? So those are some of the types of requirements. There's a few listed here. So that's one major piece, is how do we refine that model? There's a document I put together that's linked in the original emails. I probably should add it to here, where I propose one way of doing some of that. And then Kevin's got some ideas around partitionable devices, which we're going to be iterating on. And we still have a lot of work to do around many of these. So in that sense, in 131, we have this target of getting an alpha 3 that looks close enough to what we want a subset of what we want, that we can go to beta in 132. Like that's our ultimate goal. And we're gonna have to control the scope, and we're gonna have to like manage our designs efficiently to make that at all possible.
Can I add one thing here, John?
Absolutely.
Yes, I think one other aspect of this is that, John mentioned we have this initial model, which we call the named resources model. But one of the big contributions here is this framework that we built to allow you to, in the future, add more models than just this simple named attributes model. And to me, that's one of the big things that we plan on pushing for, alpha 3 and then beta in the next release is this framework. It's not just the model itself, it's the framework around which we can insert new models in the future. And that's what we really want to solidify and get to beta quality by the next release. Because then we can just start iterating on new models as new requirements come in and we realize, oh, this model doesn't actually fit that. Okay, well, let's design a new model for this piece of hardware. And but we know that the framework we put in place 2 releases ago could actually handle all of that.
Right. Yeah.
Yeah.
So exactly. That's a huge piece is what are the extension points? How do we define them to be flexible enough that we can meet the new requirements while still, allowing them to be consumable by the upstream, by the upper layer of the control plane.
Yeah. Perhaps, yeah. It's worth adding that we also intend to keep the classic DRA. So what was originally introduced as in 126, the scheduling of a pod with pod scheduling context and all this control plane controller part of a DRA driver, at least the intention is to also keep that going forward until we are absolutely sure that we don't need it anymore. So if someone wants to do prototyping, that option will still be as alpha in 132 if we go ahead with that plan. It means that we need to shuffle around our caps a little bit, change what the feature gates enable, which aspect of a current implementation, but that's all planned for 131. So that in 131 we will have 2 feature gates. The additional dynamic resource allocation will be for the support of the structured parameters. And then there will be another feature gate named to be decided to enable the classic DRA. And the promotion to beta then will be for the structured parameters and all of the components, the framework, as Kevin said, that is needed to use those structured parameters.
Yeah, exactly. That. So, so what do we need to do now? Our next steps, right, are to refine that model. So that's one of the major pieces, right? So that we can meet more use cases. That means we need use cases. So what we have right now is a lot of use cases from Kevin, which is wonderful, but there are more vendors than just NVIDIA. And so I would love to get more use cases from those vendors. There are also needs of the consumers of these APIs. By that, I mean, like Workgroup Serving has some ideas around, I think, some new workload controllers, things like that. We need to understand how those things will be consumed and make sure that what we're building meets those requirements. That applies both to the model and to the next big piece I think we need to address, which is the consumption APIs. So right now we've got a set of consumption APIs that includes a resource claim, resource class, resource claim parameters, vendor CRDs, and I certainly and others wonder if there's a way to simplify it. So I think that's something we want to look at in the 131 timeframe as well. If there's a way we can have fewer indirections, maybe fewer objects. And I don't know if there is, because all of those pieces in that puzzle are there for good reason. We've debated them pretty extensively. But nonetheless, it's something that I want to consider, and that's something that that we would want input from work group batch, work group serving. And I don't know, I think I saw Clayton's here. Clayton, can you give us an update on work group serving and where things stand, and or if Sergey's here? And maybe what some of those pieces you're planning to build through that work group. Are we in a place, do you think realistically you'll have enough inputs for us in the next 4 weeks, which is basically how much time we have to get this design done, that we'll be able to take those in consideration? I thought I saw Clayton and Sergey on here, or Clayton at least. It's gone into hiding.
Sorry, tracking 2 calls at the same time.
Caught you. What I was asking, Clayton, if you can, is to give us a quick update on work group serving, because I do expect it will provide inputs to how we build the APIs which it consumes, and I want to know whether we'll get anything out of you in the next couple of weeks, which is when we would need it.
Okay, so Sergey's working to draft the PR. We would probably try to schedule a meeting. I think we're a few days behind you all. I think we can definitely try to have an initial list of key things we'd want to provide as inputs to working group device management. By mid next week, it's going to be really tight. So I think, a little bit of focus on if I think we'll probably be able to talk to the people who are kind of interested in working group serving already. We may not be able to get a whole group to do it, but we can definitely get some stuff back.
Okay. Okay, good. Okay, so it looks like there's some questions in chat. Do people want to ask some questions about the scope? The next steps, by the way, are to get the scope fully defined. That's in the charter there. At least it doesn't have to be like really detailed scope. It's already probably too detailed for the charter. But this document, the charter, we need to get that real clarity. Somebody was asking on chat about interconnecting multiple devices. So we're kind of calling that what we would call a compound device. The existing DRA can support this with an extra driver that understands 2 other drivers, which is not ideal, but it works. Yeah, so I try to separate. So let's separate out a couple of pieces here. You're asking how to interconnect. So there's 2 aspects of that. One is the selection and allocation of those devices, and then the other one is the actuation, what I call it, the actual configuration of those devices. So those are done by completely separate subsystems. So the selection and allocation needs to be done by the scheduler so that it's visible to the control plane. So what we need in the model is a way for the APIs the user uses to express what they need out of the devices. We need an API for them to express that they need these 2 devices and they need some sort of affinity between them. And then the scheduler needs to take that into account. So the model needs to present enough information that we can take that into account. And then finally, that decision that it's this GPU and this NIC, for example, that go together, which are by different vendors with different drivers, that decision has to somehow be made that they're associated somehow with one another. And then those different drivers that configure those things have to pick that up and make the right choices. So those are kind of the pieces we have to connect, and that's definitely in scope. But we need to do that in a way that the drivers don't need to know anything about each other, And ideally, that we don't need a driver that understands other specific drivers. It could understand that there are other drivers, but like, we don't want to get into a situation where like, oh, you can use an NVIDIA and an Intel NIC, but not an NVIDIA and a Google NIC because people didn't, add some piece of software somewhere. Like, the data needs to be published. Now, I'm not sure how to do that yet, but that's kind of the overall goal, is to make sure that these things are independently developable.
Yeah,
Kevin,
I think,
looks like.
I think the point is that it's all in scope. It just probably won't be solved within this release cycle. It's somewhat orthogonal to the what I'd argue more important things that we have listed as in scope right now. But it is something we need to tackle soon.
Exactly. And that I think is our next step. Like, so what I'm gonna ask, like the main goal of this meeting is a kickoff, right? So like, one, it's to get names next to these buckets, which we've done a lot, which is awesome. I see people going in like crazy and putting names in. And two, is to kind of kick off how we scope it. And it's exactly what Kevin said. Like, all of this comes down to, what can we do in this next release? All of this stuff's in scope, but what can we actually deliver that has incremental value to our users, and is like on a continuous path that we can grow, right? We can't make, once we go to beta, we can't make a shift. We can't make a big shift in API. So they have to be extensible. Right now, as far as I'm concerned, like, everything that's in alpha, I tend to be more aggressive than most people in the Kubernetes community. I think I don't care about burning people who've been using alpha. So that's my opinion. Others have different opinions. But like, as far as I'm concerned, like, it's so much more important that we get it right than that we don't burn alpha users. Like, the whole point of alpha is to try and figure out how to get it right, and that means you're going to get burned if you're using alpha. So that's how I see it, and that will be I will be pushing for that as much as I can. That doesn't mean we're going to change anything. I'm just saying I want us to keep that mentality. I don't want us to think we have to preserve extensively previous users. We don't have to distort what we deliver to accommodate previous alpha users.
Fully agreed here. At a public service announcement, 131 will break several APIs that have been in use for quite a while now. So if you are now investigating DRA in 130, be prepared to update your DRA drivers for 131. We have been careful about not breaking things too much in the past, but that was only because it was fairly easy to support a few minor changes without breaking drivers. But 131 will have several breaking changes. Exactly for the reason that you mentioned. We want to get everything right in 131 without distorting the implementation or the API, so that we can take that APIs and that implementation to beta in 131 without making major further changes.
Yes, exactly. Okay, so Neha is asking, can we get an ETA to fill the use case doc? Yes, I think that's super smart. So I'm backing up, and people, challenge my math if I'm wrong. I'm backing up from assumptions based on, past history of releases that we're probably going to close Kep freeze sometime in early to mid-June. Is that right? Am I doing my math? Or was it, no, maybe I did this math before vacation. It seems to have fallen out of my head since, but I don't want to do the math sitting here on the call. But my assumption is that we will hit Kep freeze probably by the end of May, or by early June. So the thing is that that's not our target for design completion. We need to back that up at least a couple of weeks, because the reality is that there's not very much time between Kep freeze and code freeze, and people will need to be working on this stuff well before we get to Kep freeze. And so that's why I come up with 4 weeks, like say by the end of, yeah, by mid-May, we should kind of have our designs done. Does anybody agree with or disagree with that, or does that sound right to people? Lior?
Yeah, not on that comment, just a different question. So finish this first.
Okay, and any Patrick or Kevin, your thoughts on that?
That may be right. I haven't looked at the timeline actually.
Okay.
What I can share is that I fully intend to get the current caps updated as quickly as possible so that we can use those documents as the starting point for more incremental changes. So I have one cap update pending that I still need to get approved by Signode that just mirrors
They got
the
approved.
okay, so that'll go in fairly soon. My next step is to pivot the caps around so that what's currently the structured parameters cap is the main cap of everything that we want to promote to beta.
Okay.
And the classic DRA will be treated as an add-on with additional use cases that are justifying why we still want to keep that, and a second feature gate. And that restructuring of a cap needs to be done soon, and merged. And then this is just an editorial thing, basically. No new features, no changes of a design in any way. So hopefully this can go through quickly. And then we have texts that can be that can be modified in certain places to add the things that we still want to do in 131, perhaps even in different PRs from different people in parallel without too many conflicts.
Okay, that's good. So what I did is I tried to capture next steps here.
Well, one other
kind
thing
of
I'll
like-
add to, sorry, what
Go
you
ahead,
and
Kevin.
Patrick both, yeah, one other thing I'll add to what you guys were just saying is that, at least historically with a lot of the DRA stuff we've been doing is that we'll end up implementing what we're also writing caps for. So the design and at least prototyping of the implementations being done in unison. So, so that if and when the cap does get approved, we don't have to change too much by the time we actually go to try and get it merged into the code base. So just a philosophy around how to kind of push some of this stuff out. Since we know we're moving forward with it, it's not a completely new thing. It's somewhat more advantageous to do things that way so that you're not stuck trying to cram the implementation into a shorter amount of time.
That's
Yeah,
absolutely true. But at the same time, my experience also has been that once I had a working prototype of something and I wrote the course or I updated the cap in parallel, then during cap discussions, some major state changes were still being suggested fairly late also in the cap freeze. So prototype is good, but ultimately it all comes down to still being responsive and active when it comes to actually getting the feature in and making some even adjustments even during the implementation work. So I fully expect this will continue for something like a feature of this scope. But yeah, you're right. It definitely doesn't work to just write a cap document with some rough ideas, and then after that has been approved to start with implementation. That doesn't work.
Yeah, and what I'm hoping for out of this process is to try and move a little more of that design prototype implementation work forward compared to what we did the last cycle. So that's why I'm kind of pushing for like the next 4 weeks, because I don't want to risk missing the date. So we have the existing DRA, which covers a huge amount of it. I have a prototype for some of the ideas for how to tweak the model, some specific parts of it. And then we can also layer in prototype. I don't know, Kevin, if you have prototypes for your partitioning ideas or just thoughts right now, but like we can try and layer in some of those ideas into a prototype, which then can eventually make its way into reality. You're on mute if you're
Yeah,
talking.
so,
Kevin.
yeah, I have working code that does it, at least in one of the forms. But
Okay,
yeah,
awesome.
I want to get it written down in the doc though, not just
Yeah.
in code. So.
I think
Yeah.
the important part actually is that we need to get the cap updates merged earlier than the cap deadline. That is what
Yes.
has been a problem in the past. I think that's where we now need to be a bit more aggressive about really scoping out some changes that we all agree on, get those cap updates merged so that we know that this is really an agreed upon API change or interface or use case that gets addressed, and then can do the work on the final implementation in parallel to further changes to the cap. That is what hasn't worked in the past, because there was always one big cap update that got pushed through to the very end of a cap review period because it was large out of, well, various reasons. I think hopefully with 131 we can get to a point where the cap updates will be smaller and more focused.
Yeah. So I want to get back to, before Leah, I want to get back to Neha's initial question. I guess in my mind, in the next 2 weeks, like I would say by the end of April, let's see a good draft of the use case documents. You can look at Kevin's document, which is quite thorough, for a bunch of use cases. I think what we'll want to do is, the sooner they come, and Neha, I'm looking to you specifically to kind of run the show there and make that happen. The thing that I want, though, is to do that iteratively, so we can ask questions like we do on all these documents, and kind of narrow down. What we're trying to do is take those use cases and boil them down into what kind of abstractions do we need, what kind of APIs do we need, and so one abstraction or API might meet the requirements of several use cases. We're trying to find those common pieces. So the sooner the better. Let's try and have a good draft that covers most of what we're going to scope by the end of April. Say.
I like that. I like that plan. Yeah, sounds good. I would definitely need help from all the volunteers. But yeah, I like the plan.
Okay. Leon.
Yeah, I just wanted to ask, where can we find more details about the framework you were talking about? Is this the structured parameters cap, or
the structured parameter cap provides kind of, yes, the overall framework, what the user facing APIs are, how the scheduler uses it, how the cluster autoscaler uses it, and then it talks about those sort of named attribute model in there, and then I have another document with a prototype for adding per device capacity, and some other, and trying to address some of the topology concerns, although not adequately. So that's kind of an experimental place right now for some of these additional features that I would love others to contribute and iterate on in that framework, how we might meet some of these requirements, and then we'll see how that model fits into the overall larger DRA framework over the next few weeks.
Let me extend that answer a little bit. Right now, you should be starting with core or classic DRA, the original cap, because that introduces the overall design, the core APIs like resource claim, resource class. And then once you understand that part, you can move on to the structured parameters, which is currently described as an add-on or an extension. Once I'm done with a restructuring of these caps, you can start with structured parameters cap and stop there. It will be a complete description of everything that will be needed for structured parameters, but it's not at the moment, not yet. So.
And again,
so if you go back to the email, and I can add this in the agenda, it's just hard to do during the meeting. In the email, we have, which is if you go to the Google group, the dev at Kubernetes.io Google group, you'll see an email about the formation of the accelerator management, which is now device management work group. And in there, I listed a link to the classic DRA cap, to the structured parameters cap, to, I think, to Kevin's use case document, and also to the model design doc that I put together. I think all of those things are there. I'll try and add those back into this agenda as well.
Yeah, I read them. And just in your prototype, do you have a specific device, like vendor that you're experimenting with, or is it?
No, the prototype is only on the scheduling and allocation side. It doesn't touch anything beyond that. So it's very basic. It doesn't even really, yeah, it's more, what I was going for there is one, I wanted to experiment with how we deal with per device resources. I wanted to experiment with how we allocate those across topologies. And something I had in my original prototype, which I took out to simplify things, but now I found out was an invalid assumption to take that out, is the idea of splitting a capacity request across a resource request across multiple devices. So if you think about like in classic Kubernetes, when you have a resource request for a pod, you're going to satisfy it with one node. We only ever run a pod on a single node. But with the devices, it's actually quite different in that if you could have a capacity request that you can ask for multiple devices effectively, right? So an individual pod or container can be associated with multiple devices still on the same node. But so that means that if you make a request for, say, 80 gigabytes of GPU RAM, the question becomes, do I have to satisfy that with a single GPU, or can I split it across multiple GPUs and allocate 2 GPUs to that workload, that pod, in order to satisfy that? And then the question is, well, if I do that, is there overhead associated with that now I somehow have to take into account? So I think there's a lot of questions there still. It's not clear to me like how to resolve, but those are some of the things I'm trying to experiment with. We do that with topology today, like NUMA topology, right? You can allocate memory from a single NUMA node, or you can break it across NUMA nodes. It's a similar kind of problem, but not quite the same.
One other thing I'll add there, and sorry, I can't seem to figure out how to raise my hand, so I keep jumping in without raising my hand.
That's okay. Yeah.
Right,
Go ahead, Kevin.
We have an example device driver for all of this. So if you a talk I gave at KubeCon EU 2023 goes through the process of how does DRA work behind the scenes and how do you build a device driver for that. Again, that's with the classic DRA because we hadn't done the structured parameter stuff yet. But if you watch that video, it should give you a good overview of how DRA works in general and how you build a device driver for that. And one of the things that talk points to is that we have an example device driver repo underneath Kubernetes SIGs. I think it's called Kubernetes SIGs DRA example driver. And that shows you all the mechanics of what's necessary to build a driver against DRA and have it work with a kind of mock device. I'm in the process of updating that to work with structured parameters. I have a branch that I don't think I've pushed publicly yet. But the update to make it work with structured parameters is fairly straightforward. We just don't have a lot of documentation or presentations around that. And then on the side of all that, the DRA driver for GPUs that we're implementing in NVIDIA, we keep up to date with all of the stuff that's going on in DRA as it happens. And so I have one that works with classic DRA. I have one that works with structured parameters. If you want to test those out, if GPUs is the use case you're interested in, you can look up that and start playing around with that as well.
Yeah, awesome. Thanks. It'll be useful if you also follow up with some links, maybe in this agenda doc or.
Sure.
Yeah.
No problem. Sorry, Abhishek.
All right, sorry. Thank you, Abhishek, for being so patient.
No worries. So I mean, just a minor comment. I know we are trying to move fast and build some prototype, but it would be, it's a sincere request that we not build prototype on top of a vendor hardware. So if we can build prototype that works with something like example DRA driver, then that motivates more users to try it out, to test it out, and give more feedback. So just a request that maybe we should try to make this work with this example DRA driver or something else which is more suited for the next version.
Yeah, I think that for sure. So somebody else also commented about EDE testing. I think that we want to build we should build at least one, if not multiple, drivers that exercise the machinery. They don't actually need to actuate anything on the node because that's not what we're trying to test. Like that's the individual vendors that do that eventually. If there's some part of the machinery we need to test there, like interactions with kubelet, we might want to do some pieces there. I think, Kevin, you said you've got one that just like injects environment variables or something like that.
That's the one I
very
was just
simple
talking
thing.
about. Yeah,
What's that?
that's the one I was just talking about.
Okay.
With Leo. Yeah.
Yeah, right. That just does something very basic, or mounts something in the container or something. But like, what we should do is those example drivers or test drivers should exercise all the machinery, right? So that means they should, if we come up with the idea of partitionable devices, they should exercise the machinery of partitionable devices. If we come up with per device resources, they should exercise that machinery. If they come up with the idea of a compound device that somehow we have some topological affinity or what, I don't know exactly what, between two things, it should exercise that and make sure that the data that would be needed by each of the independent drivers is made available to them properly, right? So I think that totally agree. We need that.
All right. Yeah, looking forward to seeing that effort, and if any help is needed, I can certainly help. Yeah.
Awesome, thank you. The other thing, Abhishek, you brought up, I believe, multiple times, failure management. So that's an area I'm not entirely clear on what we can do about, and what is sort of like within scope of this group versus within scope of, say, work group serving. Like, we should have that discussion and try to understand what from an end user point of view, your thoughts are there. And I know I've got some folks here at Google I'm going to reach out to who've been thinking about that as well. But again, that'll be part of this coordination process and this development of the eventual use cases and requirements documents.
Yeah. I mean, just very briefly, quickly. I mean, I'm familiar with NVIDIA GPUs, so I mean, at least I think that NVIDIA SMI gives me more better error codes than they are present inside a Kubernetes object. So the first step would be maybe making the objects inside Kubernetes well aware of the errors that happened on the GPUs. So that could be a step in fault tolerance. Is what I think.
Okay, so that's for the how would you see using that as a user? You would see those failure codes, or do you expect some tooling to read those failure codes? Like, what I was imagining is if a device fails, then the pod fails. So your choice becomes: do I find another device on the same node that we can use to replace it? Is there a way to do that, or do we have to destroy the pod and create a new pod? Like, right, those are the kind of, and then so when failure codes get propagated up to the control plane, is it a user looking at those, or is it some tooling on top of that, like something from workgroup serving that says, oh, that part of this larger workload has failed, we need to do something to manage it? So yeah, exactly. That's exactly the kind of question.
So I think that's step 2 probably, but I mean, step 1 is when a pod failed. I think right now we don't know the reason. Did it fail because of a hardware failure, or due to an app failure, or due to something else? And we want to distinguish that better. So
I think that is an excellent example of a serving and device management crossover point. Like, there's no reason that a workload administrator should have to go down to the hardware to know that a pod failed because of something that we could identify as a hardware failure.
Mm-hmm.
Awesome. Okay, good.
Could we? I just have a question. Would it make sense maybe to add this as another work stream? So fault tolerance.
Yeah, it absolutely does. So I have in here, I have it. I had something. Yeah, this. Right, so that's as much as another work stream as I have right now, right? It's just a bullet point here, but that's, yes, 100%. And if there's other, so the idea here, and people please, like somebody added conformance, these things have been added by others. like, go ahead and if you've got ideas of like areas of scope we need to address, please add it in here. It doesn't guarantee we're going to do it in any specific time frame, but that'll be what part of what our next discussion is over the next few weeks. Like, but I want to make sure that we're all contributing, because that's
Yeah, that was needed at the conformance framework, and it's somehow related as well to like the example with, I don't know, maybe failure codes or something. And because we had the same thing in Getter, right? Like, we're gonna have some generic APIs without default implementation, and like, those device plugins gonna do the work. But then I think we should, I mean, if not as like one of the first use cases, I think we should like come up with conformance framework to like make sure portability, and because if we get to the state where every device is doing something different, so then we're not providing the best user experience as Kubernetes. So yeah, I think
that.
this is something to look at.
Yeah, I think that's definitely a reasonable thing to look at. Like with Gateway, there's the conformance of the drivers to the spec. Right now, it's sort of it's a little different than I think it may be a little bit different than Gateway, but we'll see. Like right now, there's a set of upstream APIs that the drivers will be using to interact with the scheduler and autoscaler. And then there's a set of vendor APIs that are opaque to the control plane that kind of get passed through. So in some sense, we might be, if you use our APIs, you're conformant. I'm not sure what other behaviors there might be, but we should think about that. Like, is there a way, is there a set of practices that we expect drivers, and can we test for those and certify the drivers? I think is a good set of questions to consider.
Yeah, I mean, they're probably like I'll need to learn more about specific use cases, but they're probably going to be some core use cases where, I don't know, like GPU assignment or things that are supported, like some different vendors support them. And I think we need to standardize on like what are the things we consider as core, and what are the things we consider as like maybe implementation specific things, and then to understand if and how we can go ahead and develop some framework that gonna check that. Or I don't know, I don't really familiar with the failure code example, but like, for example, if a device cannot assign something, or there's a failure in a pod or something like this, so how do we, maybe it's something we want to enforce, like the device plugin should return, or
that could be, yeah, there could be. So one of the things I want to mention is we talk about per device resources, and I think failure codes is another example. Like, at least initially, like if you think about per device resources, like in compute, we have, CPU and memory, and we don't care, and maybe we should, but for the most part, we don't care about what CPU or what memory that is. It's going to be a little different here, at least for the next couple of years. Like, there's no expectation that we'll come up with a universal GPU memory that can work across multiple GPUs. We don't even know that such a concept makes sense. Like, so right now, it's more about like NVIDIA will publish the NVIDIA specific resources that matter to NVIDIA users, and whoever else will publish those. There wouldn't be like a common attribute across the two in general. We don't, I don't see that as something we're doing anytime soon, because I don't think we would even know how to do it yet. Maybe I think the framework will be there, that if someday that makes sense, we could potentially do it, and the vendors are on board with it. Like, but it's so in that sense of common use cases, like I think right now it's still very specific to like, I want an NVIDIA GPU. I think because the way the workloads are built, like it's just too much machinery around it. We're very close to out of time, so I think Olivier, yeah. Did you have a comment?
Yeah, no, it was more of a technical comment on I think when we talk about this cross work group and serving, and Clayton was talking about that, right? There's a question of preemption. I think that I also want to call out here as something we you know we are addressing, but I think there's a question of how much or how well. But I think it's a longer discussion.
Okay, well, let's put it in the document as something to discuss. I think that there's a question of what's supported by the underlying hardware when you start talking
Yes.
about preemption and disruption of workloads and things like that. Okay, with just 2 minutes left, I just wanted to emphasize, thank you all for being here. Like, this is more of a kickoff. I think we got some discussion of scope. We got some people to sign up for some things. The next meeting will be in 2 weeks, same time, but we will be substantially discussing things on Slack. Right now, that's the DRA channel in Kubernetes Slack. Once we get official work groupiness, I think that we'll end up with our own work group Slack channel, our own work group mailing list, our own work group Zoom call. That's why I just use SIG-Arch for now. But that needs, I think, to get the charter approved. So anybody, I'm going to be pushing that to steering in the next day, probably tomorrow. So if you want to do anything, comments on that charter and get your input in there, please do it in the next 24 to 36 hours, or let's say 24 hours. And then I'll push it to steering tomorrow morning, my time. But also join the DRA Slack. I think that there's a lot of work to do. I don't want to wait 2 weeks to do anything else. We're going to be iterating extensively over those next couple of weeks. And I'll be getting in contact with all of you who signed up for something and trying to coordinate things. Any other quick comments before we adjourn? Okay. All right. Well, thank you, everybody. I'm excited to get started. I think we got a lot of good work to do, and looking forward to working with all of you over the next however long it takes. Thanks so much.
Thanks, John.
Thanks.
Thanks.
Bye.
Thanks.
Thanks.